Welcome back. So one of the other things that I wanted to talk about was, I think in the class we discussed figuring out, when you write some C, what kind of code does it become, right? So uh, let's uh, let's take a look at that and just see how and where we can see what we get as the output. Okay, so let's say this is your code, and let's first do a clean. Okay, so clean project. And what I'm going to do is, let's go and look inside this folder that we are working in. So this is our cystic interrupts folder. This is basically all of the files that are being generated, and the files that get generated are all inside this. Okay, so I think in the class we have already looked at this map file, which basically tells what got allocated where in memory, which is the linker's sort of result, right? So it's a summary of what the linker was able to do, but it doesn't really have anything else. I mean, other than the fact that um, the object files and the final executable got generated. So let's take a look at that. So let's do a build, and you will see that you can see all of these got generated. So what are the files that got generated? Let me just sort them by time so you know what got generated. So first thing that got generated was the these make files, which again, don't worry about the make files. Main.obj, which is the object file. Then there was the startup .obj, and then this out file. So all of these got generated uh, during the compile process. But we want to see what is the assembly that got generated, and that we can't see here. So to do that, what we do is we go to, I think, somewhere here in the build settings. And what I'm going to do is, I'm going to go to this ARM compiler, and I'm going to say you keep the files that the compiler generates. So let's go see where those are. It's not here. There we go. Keep the generated assembly language files. Okay, so you're going to do this, and we are going to say build again. Okay, and now let's go and see in our folder what is it that is new from last time. And you'll notice straight away that main.asm should show up. So where is our main.asm? There we are. So let's open our main.asm and see what it looks like. So main.asm, this is what it looks like. So even if you don't have the board, at least you can look at what is going on and what is the kind of assembly that is generated. So you can see this was our the function, right? So this branch GPIO port finit. So you can see that this label should exist somewhere. So let's see if it's there. There you go. So this is a thumb function. All these attributes and all these are all for the sake of the debugger, and for later information. Those are not actually assembly. The only assembly is here. So you can see this is port finit, which is basically LDR something, which basically means you load some value into this, then set this to 0, then or something, then store it, right? So that's basically what is happening here. And then let's see if we can find our interrupt function as well. So Control F, handler, because our function is called cystic handler. So let's see where that is defined. There we go. So this is our cystic handler, and you can see what it's doing, right? So we are incrementing our function. So what was it that was getting incremented? So cystic count was getting incremented. So that is incremented here. And then we are doing a check, right? So we are comparing it with 1000. So we want to see, has it reached 1000? So If yes, it should if it's not equal, then it should branch out. Otherwise, it should just continue. So what where does it branch? It branches to this L2, C2, L2. Otherwise, it runs through all of this. So what is all this? This is basically the place where the GPIO pin gets toggled. So you basically have a read and then there's an XOR, right? So let's see if we can spot that. So this is the XOR statement and then store. So read, do the XOR, then store it back. So that's what is happening. So this is how you look at the assembly that is being generated. Okay. Uh, the other thing that I wanted to just point out is the CMD file. This is your linker command file. This tells the compiler, or this tells the linker what memory is available on the chip that we are using, or off chip if at all we are using that, and what is the size, how much memory is there, what type is it, and then what kind of things have to go there. So for example, the interrupt vectors, right, they have to go starting from location 0000. Okay, then the SRAM, it starts from location 2000, 2 million. Well, not exactly million, it's in hex, so it's 2000 followed by 4 zeros. So that is the configuration of our memory. So that's what the linker file tells. So that's about it, and we'll come back with more interrupts in the next module.